total suspended solids is a water quality parameter used for example to assess the quality of wastewater after treatment in a wastewater treatment plant. It is listed as a conventional pollutant in the U.S. Clean Water Act. This parameter was at one time called non-filterable residue, a term that refers to the identical measurement, the dry weight of particles trapped by a filter, typically of a specified pore size. However, the term non-filterable suffered from an odd condition of usage. In some circles filterable meant the material retained on a filter, so non-filterable would be the water and particulates that pass through the filter. In other disciplines and dictionary definitions, filterable means just the opposite, the material passed by a filter, usually called total dissolved solids, or TDS. Thus in chemistry the non-filterable solids are the retained material called the residue. Measurement. TSS of a water or wastewater sample is determined by pouring a carefully measured volume of water through a pre-weighed filter of a specified pore size, then weighing the filter again after drying to remove all water. Filters for TSS measurements are typically composed of glass fibers. The gain in weight is a dry weight measure of the particulates present in the water sample expressed in units derived or calculated from the volume of water filtered. If the water contains an appreciable amount of dissolved substances, these will add to the weight of the filter as it is dried. Therefore it is necessary to wash the filter and sample with deionized water after filtering the sample and before drying the filter. Failure to add this step is a fairly common mistake made by inexperienced laboratory technicians working with seawater samples, and will completely invalidate the results as the weight of salts left on the filter during drying can easily exceed that of the suspended particulate matter. Although turbidity purports to measure approximately the same water quality property as TSS, the latter is more useful because it provides an actual weight of the particulate material present in the sample. In water quality monitoring situations, a series of more labor-intensive TSS measurements will be paired with relatively quick and easy turbidity measurements to develop a site-specific correlation. Once satisfactorily established, the correlation can be used to estimate TSS from more frequently made turbidity measurements, saving time and effort. Because turbidity readings are somewhat dependent on particle size, shape, and color, this approach requires calculating a correlation equation for each location. Further, situations or conditions that tend to suspend larger particles through water motion can produce higher values of TSS not necessarily accompanied by a corresponding increase in turbidity. This is because particles above a certain size are not measured by a bench turbidity meter, but contribute substantially to the TSS value. Definition problems. Although TSS appears to be a straightforward measure of particulate weight obtained by separating particles from a water sample using a filter, it suffers as a defined quantity from the fact that particles occur in nature in essentially a continuum of sizes. At the lower end, TSS relies on a cutoff established by properties of the filter being used. At the upper end, the cutoff should be the exclusion of all particulates too large to be suspended in water. However, this is not a fixed particle size but is dependent upon the energetics of the situation at the time of sampling. Moving water suspends larger particles than does still water. Usually it is the case that the additional suspended material caused by the movement of the water is of interest. These problems in no way invalidate the use of TSS. Consistency in method and technique can overcome shortcomings in most cases. But comparisons between studies may require a careful review of the methodologies used to establish that the studies are in fact measuring the same thing. TSS in milligram per liter can be calculated as dry weight of residue and filter, dry weight of filter alone, in grams/ml of sample 1 million. See also, bed load, settlable solids, turbidity, water pollution, water quality. References